Hello students and family members, this is Mr. Panza. Welcome to our test prep review video on our unit that deals with time. The first thing we went over, one of the first two lessons we went over, how to tell times in two different ways. The regular way, like on a digital clock, and the smart way, using words after and before of or till in describing times. So you can see our first question deals with telling time in two different ways, the regular way and smart way. So very quickly, students are able to identify clock number 1 as being 5:12, clock number 2 as being 10:30, and clock number 3 as being 5:45. The new way that they maybe learned this year, and I helped learn them a trick to figure this out, is by labeling a clock, and we call it the smart way. So because the clock minute hand is pointed onto the right-hand side after I split the clock in half, I'm going to use the word after. In other words, this is 5 minutes after, the 2 would represent 10 after, the 3 is quarter after, this is 20 after, and in between the 20 and 25, those little tick marks would be 26 after, 27 after, 28 after, and so forth. So if the 2, which is where the minute hand has just passed, is 10 after, then this is 11 after, and that is 12 after, which means my smart time would be 12 after 5 o'clock. Now, these next two deal with either quarter of an hour or half hours. So in this case, because our minute hand is pointed at the 6, we say that as being half past the current hour. Well, since the current hour is 10 o'clock, the way that we would say that is half past 10 o'clock. We wouldn't say 30 minutes after, even though if the minute hand were just 1 minute before and it was at the 29 tick mark, then we would say that as 29 after 10. The same goes for when the minute hand is either pointing at the 9, like in our example question number 3, or the minute hand is pointing at the 3. If it's at the 3, we say quarter after, because it's on the right-hand side. However, because this minute hand is pointing to the left, we say quarter of. And because the hour hand is pointing close to, but not directly at the 6 yet, you're going towards or closer to or until the next hour. So we say that as quarter of 6 o'clock. As we move down, now we're dealing with elapsed time. Elapsed time is the time that passes from when you start something to when you finish something. We showed the students a strategy called the mountain, hill, and rock strategy. That's just a very quick picture diagram timeline so that you can determine how much time has passed. So the first thing you need to do is build your start line, and then also give yourself the start time, which in this case would have been 4:55. That's my start time. Now, can I start with a mountain? Well, a mountain equals an hour's worth of time. So if I go from 4:55 to 5:55, that's way too much. Instead, I'm going to start with a hill. In this case, the hill represents 5 minutes. So if I started at 4:55 and I go 5 minutes, I've now hit 5 o'clock. It's very important that you keep a track of the times, like I'm doing here, and that you write them vertically like I'm writing, so that you know once the rainbow hits this point, that's the 5 o'clock marker. And I'm starting at 5 o'clock again as I move to another hill, adding 5 more minutes, and this time, because I've added 5 more minutes, it's no longer 5 o'clock, but it's 5:05. I still haven't reached my finish line yet, so I need at least one more hill. That hill will connect to the 5:05, and my final time then would be 5:10, which was supposed to be my finish time to begin with, which means my finish line here can move right here. And now I just need to determine how much time has passed, or the total amount of elapsed time. The one thing the student should also be doing is if they draw a mountain like I have over here, they should be placing 1 hour in there to mark it. But these are all hills, which represent 5 minutes that have gone by, which means 5 minutes, 5 minutes, and 5 minutes would equal the total elapsed time of 15 minutes. The most important thing is that they don't just leave the mountain, hills, and rocks alone. They should be showing me the final answer of how much total time has passed directly next to their diagram. Let's move on to example number 5 and see if we can't use the same exact strategy. This time you are able to use mountains. Remember, mountains represent an entire time of 1 hour. So, if my start time was 2:10, and I drew a mountain to represent that 1 hour had gone away, then that means I went from 2:10 to 3:10. I'm still not at my finish time, and I could use another mountain because from 3:10 plus an hour would get me to 4:10. So I make sure that I'm writing all of the times down to keep track. Now, I can't do any hours anymore. I can either do these little hills or rocks. If you did rocks, those would equal 1 minute, but I'd much rather just skip by those minutes and do a 5-minute time jump. So now 5 minutes from 4:10 would be 4:05. I'm sorry, I was right the first time. 4:15. Now you just need to add up. I have 1 hour, which is equal to 2 hours. I'm not done quite yet because right here is my 5-minute jump, which means if I started at 2:10 and I ended at 4:15, the total amount of time that had gone by, or we call that elapsed time, is 2 hours, 5 minutes. So from my black start line to my finish line from 2:10 to 4:15, it's 2 hours, 5 minutes. As we continue to try these other examples, you can see that this strategy really helps the students visualize how to go from a start to end, but then also how to add up all of the elapsed time in between. So there's my first jump once again. I'm going from 1:15 to 2:15. So my start time here is 1:15. I got 2:15 because I drew a mountain first, and because I drew a mountain first, that's 1 hour's worth of time. And now I just have to do a whole bunch of hills. If you didn't want to just do a lot of hills, and you could see, hey, if I go from 2:15 to 2:30, that's 15 minutes, you're certainly welcome to do that. Just stretch that hill out, maybe 2:15 to 2:30. As long as you can recognize that that's a 15-minute jump, you're in good shape. If you can't see that, then just use the fact that these are always 5 minutes. Instead, now I can create another hill. This hill doesn't have to go all the way plus 15 minutes, because if I did, that would get me to 2:45, and instead, let's shorten it up just for visual sake, and let's do a 10-minute jump this time, which means I'm now at 2:40. And if I wanted to get to my finish time of 2:44, I would need 4 little hills. 1, 2, 3, 4. You can see it's not a perfect art, but it's certainly a great visual for students to see where did you start and where did you finish. On top of that, how much time has gone in between. So go back and fill in your chart. I've got 1 hour. This was 15 minutes. This was another 10 minutes. And then 1, 2, 3, 4. So when my total elapsed time is figured out, I have 1 hour that's gone by. And now just add all of my minutes together. 15 plus 10 is 25. 26, 27, 28, 29 minutes. 1 hour and 29 minutes. There are a couple of more examples like this on the back half of the page as I skip number 7 and go to number 8. Now you can still use the mountain, hill, and rock strategy even for a question that maybe is in a word problem. Here's an example of that. Mary left her house at 4:10 to go to the bank. She returned at 5:37. So how much time was gone? Once again, your start time still starts on the start block, 4:10. Your finish line is still going to be at the very end, 5:37. And you're still trying to determine how much time had elapsed. 4:10 to 5:10. Put that there. Continue to mark your time so you don't lose track. I can't go 5:10 to 6:10 because that would be too much. So now I'm ready to use my hills. 5:10 to 5:20. 5:20 to 5:30. 5:30 to 5:35. Which means I need to end my finish here. Stretch it a bit. And 2 small minute bump rocks, as we call them. 36, 37 gets me my total and finish time. But you can't leave it like that. You've got to go back and make sure that you totally understand how much has gone by. You've got to remember that this is 1 hour. These are all 5 minutes. 5, 10, 15, 16, 17, which means 1 hour, 17 minutes has elapsed or gone by. In the sense of question number 9, you can see that we have an hour 20-minute football game and we have a start time. So you can certainly use the same exact strategy to solve this problem. First, you need to take the start time, put it at the start line, which in this case is 6:25, and realize that 1 hour and 20 minutes can be represented by using your mountain, hill, and rock strategy. 6:25 with an hour would get me to 7:25. And then I need 20 minutes represented in either one hill or multiple hills. So I'm just going to make it quick and easy on myself and do, 20-minute stretch timer. So I have 1 hour here, and this is 20 minutes. 7:25, 25, plus 20 minutes is going to get me to 7:45. So I can still use the same exact strategy to get the answer to this type of problem. Use that strategy for number 10 as well. There were 2 more quick lessons that we taught towards the end of this unit. One was trying to convert time. You need to know the basic facts. Now, I told the students I would always provide those facts for them, but they need to know how to apply them. Here are the steps. If Miss Julie ran a race that was 57 minutes, but I wanted to know how many seconds it took her, I need to take the question, which is here, 57 minutes equals how many seconds, and write the basic fact from minutes to seconds directly underneath it. Now, you've got to make sure that these match up. When I mean, I'm talking about the units. My minute must be under my minutes, and my seconds must be under my seconds. That's because now that I see 60 seconds is all the way over here, my 57 minutes is over there, that's a signal to the students that you're going to be multiplying. Why? Because they're across from one another. And when you multiply with a calculator 57 times 60, you're going to get the fact that 57 minutes is equal to 3,420 seconds. And you can do the same thing for the race that Mr. Panza ran, except this time you're talking seconds to minutes. So you have to put the 60 seconds here equaling 1 minute. And because the 2 large numbers are on top of each other, you're taking 1,140 and dividing it by 60 to determine that it took Mr. Panza 19 minutes to run this race. The other small one was understanding that short things like a pitch from a pitcher to a catcher would be measured in seconds. A medium type of trip, like a drive from Smoketown to Fritz, would be represented by minutes. And a long trip, like the flight from Pennsylvania to Florida, would be measured in hours. I hope this video helps you review for the time test coming up. Thanks. Have a good night.